Hello and welcome. We are about to do Lab E, which is where we will look at drill and Spark, specifically running SQL over just about anything. So this lab walkthrough will do just that. Let's start by firing up Jupyter Drill, min.io, name node, and data node. So I'm just going to go out here to the command line and docker compose start Jupyter name node, data node, drill, and min.io. Fire up all my favorite players here. And just to make sure that it worked, looks like everybody's running. So let's bring up a browser here. And let's get to Jupyter. There's Jupyter Lab. Let's get to drill. Let's get to web HDFS. I don't know if I'm going to need it, but why the hell not? Came all this way, right? And let's also get to min.io. So I've got all my favorite utilities up and running. They all work. I know I'm in good places. Ready to rock and roll, as we say. So let's see what's next. What's in store here? So it says web HDFS. Yeah, I did them all. Okay. It says create a Lab E bucket and then download this file and upload it to the Lab E bucket. So this is exactly what we just did. We did this in class, but we'll do it again. So I'm going to just be lazy and use the min.io web UI. I mean, I could do it from the command line. I don't know. I'm just going to go with the way that probably most of the students are going to do it. And let's sign in. Oh boy. Okay. There we go. Put an I in there maybe. There we go. And I probably already have this bucket because of course there's my Lab E bucket, right? So I'm going to delete this bucket and it's probably not going to let me delete the bucket because there's stuff in it. See that? Wah, wah, wah. So I will just quickly remove the things from the bucket and then resume the video. The bucket is gone thanks to movie editing magic, and now I can continue with making the bucket. So I'm going to hit create bucket, Labby, create bucket. I want to upload a file to the bucket, but I got to go back to my instructions. This is the file I want to get. So I will go back to the browser and paste in the file. And I got a boo-boo in there because I got a comma. There you go. And this is the file I want. Now I have to save it. So you right-click, save as. That's basically how you do this stuff in a browser. And I'm just going to call this Syracuse, New York CSV. I'm going to put it in the downloads folder. It's always important to know where it is, or maybe on the desktop. I don't know. It doesn't matter. Okay, I've saved it. It's there. Now I'm going to go back to min.io and I'm going to upload it. And I got to know where it is. Again, these are not IST769 things. These are how do you use your computer things. It seems to be that there's a lot of questions about these and not as many questions about the technology in general. Which is fine. So now I've got my CSV file there. So let's see what we have to do next. My guess is we're going to configure a drill driver and then query this with drill. That's my hunch. I wrote the lab, so my hunch is probably correct. Haha. Configure drill storage plugin to the min.io Lab E bucket. Write a drill query for Syracuse New CSV to demonstrate you can read the file with headers. Okay, so let's do that next. So if I go here and I do code dot it will open up the code editor in the current folder. And in here, you will see a folder called Drill Storage Plugins. It's the same folder that's here. If I go here and just, open up Windows Explorer, I don't know which of my many folders that popped that up in. There it is. You'll see that there's a Drill Storage Plugins folder, and in there's a bunch of JSON configs. You need to get to those JSON configs. The easiest way to do it is in here, because you can copy and paste it a lot easier. And we want to look at the min.io drill one. Okay. And we're going to change this bucket, but let's just copy the whole thing. So Control A to copy, to select, Control C to copy, Control A, Control C. Then I'm going to go back here and go to drill and go to storage. And I'm going to make a new plugin, create, and I'm going to call this Labby. I don't remember what the instructions said to call it. Labby. It didn't say what to call it. I guess I'll just call it Labby. And then I'm going to paste in my config to start and just hit create. And then you'll have a Labby here, and you can update it. And I don't want it to point to eDrill. I want it to point to the bucket that I made called Lab E. Let me zoom this in a bit. Okay, we're a lot. So Labby, and then I need to deal with headers. Right now, the CSV file does not allow headers. So if you want to see what that looks like, let me update this and go to Query. Select star from Labby dot custom. What is it? What do we got here? Let's go take a look. Syracuse NY CSV. Syracuse NY CSV. And this will query in drill. But because the header row wasn't configured, it shows up as a data row, and we don't want that. So I need to configure my storage provider to understand that when it's a CSV file, to include a header. See this extract header true? I need that. So I'm going to pretty much just copy lines 74 and 75 like this. Easy way to do it is just copy that. Control C to copy. Then I'm going to go up to lines 31, and I'm going to replace line 31s like this. Control V to paste. If you got something wrong, it'll look like this. It'll have an X in there, and the X will kind of tell you what you need to fix. I'm expecting a comma somewhere, bozo. So you just kind of have to monkey with that. And if you get it right, you should be able to drill that data like this. Okay. And then poof, there you have it. We've got a bunch of temperatures in here. That is the first question. Let's move on to the next one. Write a drill SQL query to get the overall average min and max temperatures by year and month. Use drill's split function to separate year and month. You might need to use cast to ensure the min and max temperatures are numeric types. You output, guess it should be your output, might as well fix that now. Your output should include 4 columns: year, month, the average minimum temperature for that month, and the average maximum temperature for that month. This begs quite a few questions. First and foremost, let's look at the data. We have year and month. So each row represents a year, a month, and a day. We want to roll this data up to year and month. So the first thing we must do is engineer some columns out of this. We must engineer a year column, a month column, and that's it. We don't need the day column. So how do you do that? Well, there's a function that you can use in SQL called split. which is used to take a column like this one and say, you know, where there's a dash, split it. And so this would split this one column into 3 values: 1, 2, 3. And since we computer science freaks start at 0, it would be 0, 0 for the year, 1 for the month, and 2 for the day. So if I go down here, 0, 1, 2. So let's see if we can make that happen. Let's go back to our query. And let's do split. I'm going to keep the star in here for grins. And then I'm going to say split EST. I'm going to use backticks because I'm paranoid. And I want to split that on a hyphen. And let's see what we get. See, now I get an array of 3 values. See that? An array of 3 values. Now let's engineer it further. So if I take that first value, that is the year. You see me, I type like a retired New York City police officer. So I'm going to copy and paste there. Okay, it doesn't like a comma here and a comma here. It certainly does not like that, right? It even tells me, this little caret is telling me, yo, check it out, dude, you got a comma there. Okay, I had comma, too much comma drama. There. So I've got year and month. So that mission has been accomplished. Now the question is, can I sum up min and max temperature F? Can I sum those up? Are they going to be ints, or are they going to be strings? I could be just paranoid and just go ahead and cast them, assuming that they're not going to be additive because they're string types and not numeric types. That would look something like this. Oh, cast, you know, blah, 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 blah. But let's be optimistic, which never happens with me because I know how drill is. So I'm going to sum up the min temperature. Got to spell it right. TEMPERATUREF. Let's sum that up as total. That's what I asked for, right? As average min. And let's take out the star. And now because we have an aggregate here, we must group by, right? So this is becoming a hot mess because I need to group by these. Right? So this is screaming common table expression at this point. But I'm not quite there yet. So what I'm going to do is, I think, just to see, I want to see if this average works. So I'm just going to comment these out. I don't know if this is going to work either. No idea. And let's see if I can just get the average. Okay, it says missing implementation, error in expression. Okay. So I think it has an issue with dealing with this. I can't get the average of this because it's a string. So let's try this. Let's try to cast this as an int. Let's see if this works. I might have to cast it as a float. Okay, that worked. See that? Now that works. So that tells you exactly what I suspected, which is anytime you read CSV, you have to assume that all these columns are not numbers. They're all text. Every single one of them is text. Okay, so now I have the story, and I can rewrite this to be the way I want. This is going to be min temp. And I don't remember what the other column was, so I'm going to put a star here and run this. And of course, I got a mistake because I got an extra parenthesis in there, right there. It's saying, drill saying, yo, dude, extra parenthesis. All right. it's a trigger warning. Every time you run it and you see that big red screen, you're like, oh God, help me, help me. Min temperature F, max temperature F. Min temperature F. Here comes the copy pasta. Max temperature F, max temp. I have not done any reducing on the rows, an extra comma as usual. I have not done any reduction on the rows, which is fine for now. There we go. The answer has me collapsing all of these year-month combinations together and getting an average min and average max for that year-month. All right. Now, I could go in here and group by these crazy bastardized expressions, but this is why common table expressions exist. So I'm going to embrace the CTE with, I don't know, I'll just call it temp as this query. And again, when you use a common table expression, this yields back to you in essence, a temporary view of this output with these columns aliased. So now I can say select year, month, average, min temp, average, max temp, and then I'll call this as average min, as average max, from temp, group by year, month, order by year, month, just to make sure it does it in the right order. There's no guarantee that your group by is going to also order by. That's an index thing. That's why you see that a lot in SQL Server, but in these NoSQL databases, you definitely will see the need to group by and order by. Okay, let's hope this works. There you go. So 1997, 1, it is a 15 degrees Fahrenheit min, a 31 degree Fahrenheit max. Now it didn't sort right. It goes 1, 10, 11 because again, these are strings, they're not ints, so I need to do some casting. Let me fix that. If I want to make this 100% the way I want, after I split, I need to say cast this as an int, and then let's label that year, and then I should cast this as int and make that a month, and then they're all numeric types, and then it should give me what I want. Now it sorts correctly. See that? January, February, March, April, May, June, July, August, September, October, November, December, next year. All right. So I've, in essence, solved question number 2, and here's my query to do it right here. There it is. Moving on to number 3, it says, create a view called monthly Syracuse weather averages from the query you wrote in question 2 and store it back to the lab bucket. If you cannot get question 2 working, use a similar query. So if you couldn't get number 2 working, pick some query to make a view out of it. Don't let not making a view stop you. Although you should be able to get it work because you just saw me do it. If you get an error about a mutable object, you need to change your storage config so that you can write to the location. I don't know if it's writable or not. I'm going to check that. Okay, let's give this a whirl and see what happens. So the first thing you want to know about drill is if I cut this out, right, and then put a brand new query in here, don't worry about it, because if you go to profiles, you'll see all the queries that you ran, right? So you don't have to worry about where did the query I just wrote 5 minutes ago go. It's still here. It's here somewhere. Okay, that's number 1. Number 2, let's check our storage provider for Labby, and let's see if it's writable. So see, it says workspaces default writable true, that means that I should be able to create a view in that storage provider. If writable is false, I'll show you this, false. We update that. And then let's go back to query. And let's put our query back in there. And let's say create view. And it's going to be labby dot monthly Syracuse weather average. Like that. As, and then all this stuff. Right? And then you go to run this, and it says, unable to create or drop objects, schema labby is immutable. Immutable is a fancy word for read-only. Right? So we got to fix that in our storage plugin. We make this say writable true. They should have called this immutable, because then it would match the error. But of course, we don't like to do those kinds of things. We programming nerds, unfortunately. We make people you got to know our lingo. This is why programming is getting replaced by AI. No one wants to know the lingo. So we got this going. This looks good. Let's see if it works. And it does. So it says true. Now, what the hell just happened? Let's go back to the MinIO console. Here's my labby bucket. Don't believe me? I'll just go back to buckets. Go to labby. And now you'll see that there's a drill file there. See that? There's a drill file. And if you were to download this drill file and look at it, it really just contains the query definition that's in the view. But what's nice about making a view is now you can call a select statement on this instead. For example, this is probably question number 4. Let's go take a look. Use the view you created in question 3 to show weather data only for the month of July. I can do that. I can do that. I can totally do that. I don't need any of this crap. I'm not afraid to delete it because, again, if I go back to profiles, I'll see it. See, it's right there. And I can always click on it to bring it back. Right there. Whatevs. I'm cool. I don't need that. So I'm going to go here, and what we're going to do is say select star from labby. Why did I give it such a long name? Monthly Syracuse weather averages, where, oh boy, month equals 7. There you go. Boom, shakalaka. And we just have the average mins and maxes for July staring us in the face. And maybe I want to show all of them here. Maybe so I can see a trend here. It's going up a little bit. Cool. All right, that's number 4. That was easy. All right, I'm waiting for a challenge here. The hardest part about drill, as I said 100 times before, is configuring the storage plugin. Once you get the storage plugin rocking and rolling, it's just regular old SQL. Yeah, the syntax is weird, and the fact that you have to run this query here and you see an output, and then you have to go back to query again. And yeah, that's a little wonky / awkward. But everything else is just regular, plain old SQL from that point forward. All right, what's next? Configure Spark to read from the MinIO labby bucket, then load Syracuse, New York CSV into a data frame and register it as the, and register it as the table weather. Okay, that's a mouthful. So let's first and foremost make sure that we've got Spark configured correctly. I'm going to just go ahead into Jupyter Lab here, and let's just go with a notebook. Just fire up a notebook, and I'm going to go grab eDrill Spark. I'm going to go grab this baby here. And in here, I'm going to put in this. My bucket is labby. And let's just check all the other configs. So, you know, I got Hadoop AWS. I don't need this Avro thing. I keep copying this around. I really don't need that. It's not necessary. And then there's my MinIO server. You know, this would be my Amazon, you know, S3 URL. And then this is my access key in Amazon, and this is my secret key in Amazon. And generally speaking, you keep these configurations the same. These just make it a lot easier to integrate with Spark. These are little bits I flipped because based on getting it working right. Okay, let's run that. Okay, we get our usual barfed out garbage that we don't see the second time because we've set the log level to error, but you can't set the log level beginning because it's part of the Spark context, and you can't get a Spark context until you create a Spark session. So it's not like you can the first time avoid all these warnings, unfortunately. Okay, so now let's do exactly what it asks us to do. Let's load the, what did it ask us to do? Load the data? Did it ask us to load the data? Yeah, read the data from the Labby bucket and register it as a temp table weather. Okay, I can do that. I think I can do that. Let me try. So I'm going to just call this weather equals Spark read CSV, and it's going to be on S3A. What's my bucket? Labby. I'm just going to hard code it in here because I'm just a hard coding kind of guy right now. And it's, I can't read in, by the way, I can't read in as much as you wanna. You can't read in this drill view. That's not going to work because that runs on drill. Syracuse, New York, CSV. All right, let's try this. A lot of code before you actually get to the real code. Grinding, done. A lot of columns, none of the column names came over. I need to use header, right? So add that in there. Oh, it's option. That brought the headers over, but now the types are all string. See that? String. It's the drill problem. You can handle the drill problem in Spark with infer schema. That will make a second pass over the data. To guess what the data types are. It's option, not options, Mike. There we go. So now I got string, integer, double, integer, double. Boiling trouble. Okay. So that gets me my schema. Now I think I've got something. Maybe I'll show it. Let's give it a show. And oh boy, that's fat and sassy. Let's zoom that out. Okay, that's a little better. You can see it now. It is a table. Okay, and it's got data in there. It's got stuff like that. Now that we've got that in there, let's put it in a temp view. So, you know, do I need it in weather? No, I don't. So I can just do weather, right? Create or replace temp view. And it's going to be called weather. And I don't need this variable to do this. So I'm going to, well, let me run it. Let me just do this here. Let's just show that it works. Spark, SQL, show tables. Show. Works. Now let's do this. I would write it like this. Like that. Read it, create the view right out of it, all one shot. One shot. Okay, now it doesn't all fit on the screen, so let me beautify it. Here. I would probably beautify it like this. That seems to be like a good marcation of readability right there. Yeah, I know I'm full of BS, aren't I? So there you have it. Read it in, format it. It's a CSV file. Sock it away in a temp view. One shot, baby. All in one shot. Now I can query it in Spark SQL just to show you that. Select star from weather. Okay, same thing as I did before. Believe it or not, it's just now I'm using the SQL statement instead. Okay, that's number 4. What's number 5? I wonder. I know exactly what I'm going to make you do. I'm probably going to make you do the exact same transformations that you did in Drill. I'm going to make you do them in Spark, just so that you can experience the similarities and differences between the two. That's the kind of jerk I am. Rewrite question 2. Oh, yeah, see? Rewrite question 2 using pure Spark SQL and the weather temp view. Note, there will be some subtle differences in how you must write the code. Be sure to print schema so you can see what the columns are and, of course, more importantly, what their data types are. All right. So without further ado, I'll go back there. And I like what I have here. So I'm going to just go to the next cell. Maybe I'm just going to show like 1 and keep it small. And then down here I have, maybe what I want to do is, maybe I want to put this, let's do a print schema here. Print schema. What do we got to work with? There we go. So I got some string, like this is a string. These are integers. So I don't have to do any casting of these, but I am going to have to do that split. And I wonder if it works the same way. Let's give it a shot. So when I'm writing really complicated queries in Spark, I like to use this pattern. I like to do query equals, and then triple tick it like this, because then I can write my query in here. And then what I like to do after that is do Spark SQL query, and then show that or print the schema of that or whatever. At this point, it's a data frame. You are a data frame here. And you can do whatever the hell you want, but I'll usually just show it. Maybe I'll just show the first 5 rows. Keep it thin and interesting. So let's try to do that split like we did before. Let's say select EST from weather. Let's start there. Okay, there you go. And let's try to do some splitting. So let's do split. I don't even know if this is going to work. I'm just giving it the college try, as we say in college, as dates. Okay, that did work. See, I got year, month, day. Okay, let's take this first one, and we'll call that one year. Now I'm getting really jiggy with it here, like the Fresh Prince from Bel-Air here. And we're going to call this one month. Okay, now, this is where Spark kicks major ass over Drill. I can do a print schema here to find out if those are actually strings or ints. See, they're strings. So I might want to cast those as ints so that they sort correctly. Cast that as int. You know, what you don't get when you're using Spark SQL is you don't get lovely syntax highlighting and IntelliSense. You're just writing a string. So you really have to have, I really shouldn't talk and type at the same time. You really need to have some confidence in the code, the SQL code you're writing, because you gotta be like, it's either gonna work or it's not. Okay, now I've got them as integers. Very nice. Well played, Mike. Well played. So I think let's go for the full punchline now, and let's add in there. Let's do exactly what we did before. let's add in min temperature F as min temp, max temperature F as max temp, and let's get a schema on that. And I got an error because I did something wrong. Cannot resolve min temperature F given input columns. Now, when it says given input columns, this is nice. Take a look at what they've got here. See, it's not min temperature F. It's min space temperature F. Here's the mean one. There's min humidity. So there's a space in there. That's how drill is a little different. So I need to do backatickies. Like this. I need to backtick that, baby. Why? Because there's a space in my column name. Now I could do a 2DF and fix that, but that's for amateurs. Okay, you could come up here and up right here, do dot 2DF and then rename all the columns. But again, that's for amateurs. Don't do that. You're a professional. Know how to fix it the right way and fix it the right way. These are all integers now. So I can take this and use a common table expression on this. So let's do with, I'll call it source as. That's usually what I call things in CTE world. And then I'm going to tab this all over like that. I'm going to make it look really syntactically nice. And then I'm going to say select year, month from source. And even go even better than that. Group by year, month, average, min temp as average, min, average, max temp as average, max. From source, group by year, month, order by year, month. And we run it, and there's an error. I got a parse exception. Whenever you get a parse exception, it means it tried to read this, and it's like, I don't know what you're doing. You got a comma missing or something. So you just got to look through and figure out where the hell that is. Right there. See, it says group year, month. Doesn't like that. I need the word by in there. Group by. So group by. I made these mistakes on purpose. Now I get an analysis exception, which means the parsing works, but it doesn't know one of my columns or something like that. And it says it cannot resolve max temps. Whenever you see this, that ain't a column of yours. And you can see it's called max temp. So max temp. Right, and then that prints a schema nicely. Let's see what that does when we show that. Show grinding. Look at that. It's actually doing some work. And there's your output. It was much faster in drill, was it not? Just saying. Does that mean one's better than the other? Absolutely not. Basically, you use the tool for the job that, one, your organization has available to you, and number two, you're best suited to use from a programmer time standpoint, because programmer time is programmer money. And I'd much rather have the computer spend a little more money than programmers spend a little more money. Programmers are much more valuable per hour than computers in today's world. In the 1970s, not so much. But nowadays, absolutely. Commodity. So that works. That's number 6. Let's move on and see what number 7 has in store for us. I imagine we're going to do the same thing we did before and make a view out of this. So let's take a look. Save the output from the data frame as another temp view and prove the view is there by querying it. And then there you have it. The homework is done. This is a short homework. I did this one in under an hour. So I guess I could recopy this entire cell. That's probably better form, is to just start a new cell. So I take that SQL query, create as temp view Syracuse weather averages. Spark SQL show tables just for giggles. Whoops. Screwed something up. Probably spelled something wrong. I'm going to go look up at what I did up here when I said create as temp view. Oh, create or replace temp view. Yeah, see? I knew I was going to mess that up. I usually do. Create or replace temp view. There we go. Now I've got two of them there. And I can come down to the next cell and do Spark SQL select from nope, that's not it. From where. Now I'm going to get really fun with this one. Watch this. I'm going to show you the advantage of Spark. Where, because Spark's a programming language, where month equals month. Go. Month, input, enter a month. Enter a month, 7. Boom, it blew up. I screwed something out. Oh, it's not from creator. I never changed. Oh, jeez. All right. That was an epic disaster. All right. You don't want to watch me type that again. I'm going to copy it from my notes because, boy, I'll tell you what. That's what I wanted to say there. And this is what I wanted to say here. Got to pick the right table. And now I screwed this up. Enter month. Seven. 7. Grinding. Pow! Let's run it again. Enter month. You're getting closer to what's called building a data product. Okay, so a data product is you might take an entire notebook of wisdom and then put that notebook into some kind of interactive format and then share it into your corporate intranet so that someone can run this notebook and interact with it and get analytics. So this was something that you saw kind of at the bottom of the eDrill Spark. There was a couple of Python things we did down here with interactions, graphing and 2 pandas and stuff like that using IPython interact. So I want to do that now. I'm going to, for the sake of what the helledness, what I'm going to do is plot this data and allow you to select a month. And I'm going to show you really interesting ways that you can do that. And this is all Python stuff. This is all small data stuff. The only big data stuff is right here. All right, so let's do this. So I'm going to need a couple of things. So I'm going to say from IPython display. This is the output features of the notebook. Import display and maybe some HTML. That's probably good. And then from IPy widgets, import interact manual. This is the input stuff. Right? Now, how does an interact manual work? I mean, I'm only doing this because my homework finished in 40 minutes. I figure I might as well show you some other stuff. The way that interact manuals work is it creates a program event loop where you have inputs, and then as long as you have change the inputs and press a button, it will execute the code under the function. So you have to have a function. So like I'm going to call a function. I'm going to call this function, I don't know, do it. Okay. And then in this function, I'm just going to print the number. And then I'm going to pass this number in as an argument. And then when you run this, nothing happens. I have to call the function, right? Do it 7. And then it prints 7 because I ran do it with 7. You can use the IPy widgets interact manual to decorate this function so that it will automatically call the function from the user interface. It looks like this. Interact manual. And you give it a thing number like that. And this is called a decorator function. It begins with an @ and it injects code into this. And the code that it's injecting actually runs it and then displays this as a widget. What's a widget? Whoops. It looks something like this. I have to give this a label, so number equals number. I know it looks silly, but oop, I got a mistake here. Number is not defined. Oh, I don't know. Try that. There we go. Okay. So it says number, and then, I pick a number, and then I hit enter this, and then it runs my function. Do it. It runs do it. And then I pick another number, input, run the function, do it. Pick another number, run the function, do it. Now, I don't want it to just pick any slider. I want to go from 1 to 12, and I want this to be a month, right? So now I can sort of build a better interaction here. Like, let's change this to choose month. Or just call it month. And then I want it to be a range from 1 to 12. And then I need to say do it month. Now, these have to match. This and this have to match. They got to match. And then I'll print. Let's make it fancy with an F string. You selected. You selected 6. You selected 12. You selected 1. You can, by the way, rinse, lather, and repeat this as much as you want. Like maybe you want to have month, and then you want to pick a year. And the years go from, I don't know, 1990 to 2020. You have to pass in month and year. And I won't print the year out, but see, now you've got 2 sliders. One for year, one for month. 2 inputs. That's basically how interact works. If you give it a text box up here, it gives a box where you can type in a year. If you put a list up here, the list up here, it will give you a drop down. See that? It gives you a drop down of choices. There are other ways to build other widgets, but that is probably good enough for this class. If you want to learn more, if you go ahead and look at the official IPy widgets documentation, you'll see there are a bunch of widgets out there that do all sorts of interesting things. Radio buttons, check boxes, double sliders, high-low range sliders, you name it. There's a candy for every candy lover in the IPy widgets world. So that's governing input. I guess maybe what I'll do is I'll do month and then year here. So you can see it. And then 2021, and then 10. There you go. Now, what about outputs? Rather than using print, which is boring and sucky, you can use display. Watch this. I'm going to, before my function runs, I'm going to say display with HTML. And I want to display with a H1 heading. I just put HTML in here. And I'm just going to say pick a month. How's that sound? Let's do my HTML right. See, I got a nice heading up there. So I'm not restricted to just printing boring, text out. I can format this using HTML, and this can also be an F string. So I can come down here with this F string, and rather than print, I can say display HTML. Now you might be wondering, why is it not just display and then you give it HTML? Because there's other things you can display. You can display an audio player. You can display an image. You can display a video player. There's all sorts of things you can display in Widgets. So let's do this. Let's say you selected, and then let's make this bold for month. And let's make this italic just to show you what you can do here. There. You selected 6/2020, bold italic. So see, you can do a lot of really neat and nifty things. So again, let me sum this up. You make a function. What Interact Manual does is its job is to render these as input widgets and a button. When you click the button, it runs your function using the values that you selected for month and year. It's basically what it does. Okay. Knowing that, let's make a little interaction that when we pick our month, it will display a table of data using this up here, this pattern up here. All right, so let's do that. I'm going to take this. This is great. I'm going to just copy it so I don't ruin it. And I'm going to copy this because I don't want to ruin this. And I am going to put that right there like that and change this to a month like this, month. And then I am going to change this to get year out of here. And then I'm going to change this title to Syracuse Weather. And then this is going to be just month, like that. So I only have one input, month, pick a month, then we display the averages for month. And I'll pick, I don't know, March. And it's grinding away, and then boom, there's my table. And then maybe now I want to see, September. Boom. Output. Neat. All right. That's great. This is big data. I want to make it small data. So what I want to do is, instead of show, I want to do 2 pandas. And then what you get back from that is a data frame. It's a pandas data frame, though. And then what I can do is use display to show the data frame. And then it looks even sexier. Watch. Boom. Pandas data frame. Okay. Again, this takes my big data, makes it small data. This display function displays that pandas data frame in line. I can also display a chart. So the easiest way to do a chart is you can actually attach that right to the data frame. Matplotlib is included in pandas. So I can say display, after that, display. And then maybe I want to do df plot. And on the x-axis, I want to put the year. And on the y-axis, I want to put the average min. Let's try that. Okay, boom. grinding, small data, boom, and there's my plot. Okay, it's a horrible looking plot. It needs to be better, but we'll do that in a sec. All right, if you want your plots to look better than this crap, you have to import Matplotlib. Pyplot as, I'm just going to call it PLT. That's pretty common to do. And then now what I need to do is, after I get my data frame, right, I get my data frame, I need to set the index. Okay, I'm going to display that data frame. Then I'm going to set the index to be the year column of the data frame. That's going to give me a time series type of look. And then what I want to do is plot a scatter of the data frame's year. And then to that, I want on the y-axis the I want the average min. On the data frame, I want the average min. And then, let me see how this looks. And then what I want to do is, let's just do plot show. And then we'll run the interact really quick. And you'll see now that I get my table, and then now I have my plot, and it's a little better down here. Still got weird decimals in here. But I think if I make the canvas size larger, then that will fix things. These are all Matplotlib's things, so I'm going to make my figure size larger. I'm going to go up here and say plot fig size, and I want it to be, 15 by 10. That's going to be pretty big. I can't remember what the units are on this stuff. And then let's add 2 plots to the scatter. Let's add the year with av min and the year with av max. Oh, man. Keyboards drive me nuts. Let's see what that looks like. And we're going to get that. And then we get the max and the mins. That looks a lot better. That looks much better. Mins and maxes. Maybe I don't want these to be dots. I can change them around. I can also add labels. These are all Matplotlib things, by the way. It's worth learning Matplotlib if you haven't. You should know at least one plotting / graphing library in Python. There's many to choose from. Just should know one. Let's make the marker an arrow up. Oh, this is min. Let's make that an arrow down, which is V. Then let's make the average max an arrow up. There's lots of different markers you can choose from in Matplotlib. Kind of funny. And maybe what I want to do is maybe add a legend. Like, I don't know. Put a title in here of annual temperatures. Monthly temperatures. Month. And then month. Do that. Use the old F string here. Let's try that. I mean, this is enough nonsense, I think. For sure. Man. Good Lord. Ugh. This keyboard, it's very stiff. All right, where else did I screw it up? Here. All right. Let's pick January. we're going to see our table and then our chart here. And see, these are the max, min. And I got a legend over here. Temps for month 1, January, maxes and mins. So, I mean, it's not a very good visualization, but it is a visualization, right? There's lots of ways you can do different things. Again, not really a class on Matplotlib or Plotly or Seaborn or any of those, but I encourage you to learn one and embrace it. I know a little bit about each of these. I prefer to use Plotly because I think it's just by far the easiest, and it's the one that's most cross-platform. You can plot in just about any language in Plotly. But anyway, I just wanted to give you a flavor for what a data product might look like. So in a full data product, you would just have one big cell that you ran, and then it would run this interaction, and then the interaction would be ready to go. Now, you could probably convert this big data to small data without the where clause, and that would be more efficient, and then filter it with the pandas data frame. But I'm going to assume that this data is really big data, and we don't want to do that, right? But this data is small enough where it wouldn't make sense to actually take this approach. The Spark should be up here, and then in the interact, I should be filtering the small data, not filtering the big data. And it would be much more faster and efficient. But again, we're just trying to take a big data approach, even though we don't have really big data. Okay, I think I answered all the questions. Thank you for your time, and have a good day.